Now recording. So, good morning. How's everybody this morning? I already asked that question, actually. So there's a test next week. A test for this class. So we should talk a little bit about the test before we continue on. So the test next week will occur in class, 9 a.m. Be here bright and early. Please be on time. No extra time will be provided. Although a certain amount of extra time will be provided anyways. I've decided to give you the full 3 hours to write the thing, even though it's really a 2-hour test. So, you know, my gift to you. You can have plenty of time to think about the problems. I kind of like, I don't know, this is like one of those mean professor things to say, but like, if you can't get it in 2 hours, you're probably not going to get it in 3 hours, but, you know, maybe it'll help. Maybe you just need a little extra time. So, for this test, in contrast to the Java test that you all wrote before the break, you are permitted a memory aid in the form of one double-sided 8.5 by 11 A4 piece of paper upon which you can write anything you like. The eponymous cheat sheet, crib sheet. I prefer crib sheet. You know why they call it a crib sheet? Because only babies need them. So, it's the, that's not quite true. So, the cheat sheet, right? This is properly, like, if you use it properly, it's extremely, like, valuable high-density studying. If you use it improperly, it's like no worse than having done nothing, I guess. Well, actually, no, that's not true. I'll recant that previous statement. A bad cheat sheet is actually worse than having no cheat sheet at all. So, here's the problem. Here's how cheat sheets go wrong, all right? Oh, man. Like, I've been running tests with cheat sheets for, like 10 years-ish. Way back in my university days as well, I ran tests with cheat sheets. Back in those days, I saw one guy the one time, all right? He literally took every slide in the whole course, printed them all off, postage stamp size, and just did his cheat sheet out that way, right? High density printing. Had a magnifying glass with him. He asked me in very hushed tones, "Am I allowed to have a magnifying glass?" I said, "Yeah, fine, you can have your magnifying glass." And that goes for you guys too. If you want to bring a magnifying glass, knock yourselves out. Here's the problem, right? It's not about whether the information is there. It's about whether the information can be retrieved, right? The problem with taking everything that was ever discussed in the course and put it on one big cheat sheet, you may have difficulty finding what you're looking for. The time you spend trying to find what you're looking for in your cheat sheet is time that you're not spending answering questions, right? So, when you create this cheat sheet, please do so in a manner that organizes the information in a way that makes it easy to find, right? So, if you, I'm sure everybody has their own idea about how they will produce said document. If you're stuck for ideas, here's my suggestion. First, don't set up and do it all at once. You should be doing a session a day, maybe a half an hour, maybe an hour, right? The reason you want to do repeated sessions over several days, it activates the long-term memory rather than the short-term memory. You want it in your long-term memory because you don't just need it for the test, you need it for the exam and the rest of your careers, assuming you go into anything related to web development, which is probable because that's where all the jobs are at the moment, right? So, long-term memory is activated by repeated exposures, plus in each of your study sessions, you should integrate recall. Normally, my suggestion, 5 minutes at the beginning of your study block. Take those 5 minutes and try to remember what you studied yesterday. Right? Very quickly, take a piece of paper and just jot down everything you remember from the last time you were studying. Right? The brain is kind of a funny organ, right? The path into the brain is not the same as the path out of the brain, right? We can think of this in terms of nerves, right? The nerves that you see with are not the same nerves that you speak with, right? So you have to practice both pathways, right? You have to practice collecting information into your brain that sort of opens up and widens those channels. You have to practice the information coming out of your brain as well that opens up and widens those channels as well. It's like, you know, if your system for storing mental information is to take all of your papers and throw them in a junk drawer inside of your cerebrum, that is less effective than having a filing system where you can, here's all the receipts, you know? You want to have a filing system. What is the mental filing system? Categorization. We generally think in categories, right? So, when you're making your cheat sheet, study the material, right? Go through it, read it, and summarize it. The summary should be what goes in your cheat sheet. The cheat sheet, ideally, is not a substitute for your own inbuilt memory system, but a complement to it, right? Just because you have a cheat sheet, it doesn't get you out of the work of having to remember anything, right? The cheat sheet works best when it contains enough information for you to be able to call the rest of it out of your brain, right? So that's kind of ideally how it works. Any questions about that? Does that all seem fairly straightforward? You know? Anything else to say about cheat sheets? Yes?
Do you know what topics will be covered on the test?
That's a very good question. I'm so happy you asked. It's everything up to the end of Module 2, not including the material on objects, which is listed as optional. But, just for the sake of writing things on a board so that people can take pictures of it with their phones, I'll write a list of it on the board so people can take pictures of it with their phones. So, we started this course off with a discussion of client-server architecture. We then had some topics in HTML. I don't know if you want to call that advanced HTML, but most particularly the conversion of HTML to the document object model. The document object model is a major theme in JavaScript development, so you can expect that to be, you know, if you're going to put a little star by topics, then you should know how the DOM works is a pretty big star. not just for this test, in general. We then discussed some topics in advanced CSS. What did we talk about with respect to CSS? Anybody remember? Ooh, that's a recall lecture class. We did animation, that's true.
I was going to say animation.
Anything else? Yeah?
Bootstrap?
Bootstrap I would consider another sort of bootstrap. I would put it like not under CSS, even though it's like, because that's how the course organizes it. It is a CSS library, but you know.
Yeah.
Advanced selectors. And oh no, I ran out of room for dots. Shoot. Messed me up. No, I'm kidding. CSS priority rules, right? The cascading part of cascading style sheets. So that kind of covers our Module 1 material, generally. We then move into JavaScript proper. Module 1, Module 2. Within JavaScript, we have, people sometimes wonder what I mean by this, but language topics. You guys know what I mean by that? Sort of? It's like, how does the type system work? What special operators do we have in JavaScript that we, don't have in Python or Java? What are the differences between JavaScript, Python, and Java, right? This is basically the JavaScript hates you section, right? All of those little gotchas about JavaScript that I've been pointing out over the course of the semester. I haven't been just pointing them out because I hate JavaScript, although that's true. I have intended the whole time to test you on those. So, we might even call that the language gotchas section, all right? Don't worry, it's not like half the test. But certainly, you should know how the type system works, right? Weak typing, dynamic typing, you should know what those terms mean, right? Operators, all that kind of stuff, right? JavaScript syntax, what is valid, what is invalid, all of that stuff, right? Functional JavaScript, so with respect to JavaScript, how do the functions work, right? There are specific rules pertaining to what happens when you oversupply arguments, what happens when you undersupply arguments, what happens when there's no return value, right? All of this business of being able to use function references, right? Function references are one of the things. Anonymous functions, these are also a thing, right? All of these things I would categorize under functional JavaScript. Make sense? So far so good? No big surprises yet, I hope? Yeah? Okay, good. I'm still getting over a bit of a cold. You know how they sometimes just kind of move into your sinuses for like 2 months? You know? That's where I am with them right now. Let's see, functional JavaScript. The event system. we studied three main categories of events. We studied timing events, we studied the static ones you add to the HTML directly, and we studied the ones that you add from JavaScript itself. So, as representative of those species, add click or on click and add event listener. Representative of those species. I'll put a little etc. there. Make sense? There's also a little bit about forms. You should know how to get data into and out of forms using JavaScript. But this is really as easy as like reading properties, right? So even that falls under what I would consider our final category, which is DOM manipulation. Document object model manipulation requires really only two things. You need to be able to acquire, well, three things. You need to be able to acquire references to page elements in JavaScript. You need to know how query selector works. You need to be able to read data from the document object model. You must also remember that everything you get there is a string, even if it doesn't look like a string. Even if it's hypothetically numeric, it's a string, so you gotta convert it first before you do math on it. And you need to know how to write data into the DOM. But fortunately, this is just kind of assignment statements that look very much like just regular variable assignment. So it's not too, like, this is like the fundamental building block that the entire course is based off of. So I hope that you don't have to study that too hard, because hopefully the course has provided you sufficient practice in that already. Make sense? You know, it's like if I was giving you a, let me see if I can come up with a humorous example. It's like if I was giving you a cooking test. I wouldn't consider it necessary to test you explicitly on your ability to not cut your own fingers off, but, you know, not cutting your own fingers off is a necessary skill when you're cooking, right? DOM manipulation is a necessary skill when you're doing anything in JavaScript, right? Yeah, okay. Any questions about any of that? Is that sufficiently clear? Yeah? I'd like to keep moving with a lesson today. So is this good? You guys feel confident for the test? I hear from Professor Korkegan that you guys didn't do too badly on your Java test, so good work, everyone. Oh yeah, we talk. Actually, Professor Korkegan and I have lunch together most days in the office, so. Okie dokie. So, today, I'd like to talk to you about, I'd like to get into our next topic. Our next topic will be scaled vector graphics, SVG. If everybody could please load up a code editor, that would be fantastic. you want to know why my passwords are so long, try to get me for server-side programming. I have a whole diatribe on it in that class. So, scaled vector graphics. There is a portion of this course where we kind of briefly in the middle cross paths with Java, and then we differentiate ourselves again shortly afterwards. The SVG engine, which we are about to use, is the same engine underlying JavaFX. I hope to show you by the end of this class that it's much easier to work with here than it is in Java. But it will be perhaps, it will remain an exercise to the reader. So, scaled vector graphics. A little bit of theory. Let us understand the difference between vector graphics and other sorts of graphics. Does anybody know what it means for something to be vector graphics based? Yes.
Just thinking, I guess, by the word vector, does that mean directional in some way?
Yeah, that's not a bad. That's not a bad guess. Anybody else care to guess? Yes?
You can scale the image without it losing quality, regardless of bigger or smaller.
Yes, absolutely. We can scale the image without losing any quality. This is actually true of all vector graphic systems. Has anybody ever heard of the term raster? Raster graphics. This is an older term, but it's still technically true. All right. So broadly speaking, in vector graphics systems, we represent images using a system, a geometric system, similar to Euclidean geometry. So we are talking about positions in space, positions relative to each other. We define lines as 2 points in space, and we draw a line between them, right? With raster graphics, we are looking at an array of colors, a two-dimensional array of colors, otherwise known as pixels, right? So, historically speaking, for a long period of time, vector graphics were quite highly superior to raster graphics. Let me show you, this is one of my favorite examples of the difference, right? I know I'm gonna hit an ad, but it'll be worth it, guys. So the Atari, right? The home console versions of Atari games from the arcade were often really bad, really strongly bad. Did you know it also, on average, only took them 2 weeks to produce an Atari game? You guys know about the video game crash of the early 80s? Late 70s, early 80s? Yeah? It's because Atari home console games really sucked. They were really bad. And I'll show you why. Tempest Arcade. Yeah, here we go. So this is a game called Tempest. All right? So that's pretty cool, right? You're playing as this little spaceship, you're shooting bullets down all of these little things, and woo! Did you see that? Oh, is that 3D? 3D in the 80s? This arcade cabinet came out in 1980, right? This thing blew people's tiny brains with its so awesome graphics. This is state of the art in 1980, right? Tempest! But this is vector graphics. You can see that everything here has been drawn with lines, not even volume, right? The old Atari engines weren't capable of drawing like inside of a solid, right? So that's what a vector graphic system is capable of, right? And when we work in vector graphics with SVG, without too much work, you could, well, you know, with some degree of work, you can make something that looks like this, using only like the line tool, right? Let me show you the home console version. Atari 2600. No. Atari 2600 Tempest. Let me get it. Let me see here. There it is. There she is. Video game museum indeed. They did try, God bless them. Now, is it any wonder that the young people of the 70s and 80s found themselves primarily in arcades rather than playing video games on their televisions at home? Right? Come on, that deeply sucks. You know? Also, the game only has one level. Only one level. But hey, it was able to fill these sections in, right? So for a very long time, people thought vector is definitely the way that you do computer graphics. It's just like, look at the difference, right? Well, as computers continued to miniaturize, we were able to process more and more data. And it turns out that processing arrays of pixels, you know, by the end of the 80s, this became something that was feasible. So this was basically destroyed by the game I'm about to show you. What's it called again? Space Harrier. Oh yeah, here we go, there's the ad. Yeah, I don't need a picture of you in the shower, thank you very much. Come on. Skip! There we go. So this is a game called Space Harrier. This thing won Game of the Year, I think in '87. Because just look at it, you know? So the thing that made this game interesting and unique, and the thing that made it like, the thing that defeated vector graphics, this game defeated vector graphics. The arcade cabinet had a coprocessor unit which allowed the rapid scaling of raster images. So if you see how these like, all of these little guys, like the pixels are still kind of crunchy, but you can see how it's very smoothly transitioning from the background to the foreground, right? Prior to this accelerating coprocessor, you had to have games, like you had to swap between like distinct pixels at various, or distinct images at various sizes, and you kind of like pop bigger as they got bigger to you, closer to you. A good example of that is Namco's Pole Position. Which is kind of one of these like early 3D racing games. But you can see how like, with the billboards on the side, right? They kind of pop in they go through a lot of like kind of obvious, distinct sizes as they come closer to you, right? So we're not smoothly scaling, we're not smoothly or dynamically scaling the size of the raster image in this. There are just like several distinct sprites for each size, and you swap between them as it gets closer, right? So that was kind of, when did this thing come out? This was 82. So that was not too bad. That was not too bad, but it was really Space Harrier that really kind of blew everybody's pants off. This type of thing didn't really see entrance into home consoles until, good grief, until the introduction of the Mode 7 chip in the Super Nintendo. The Mode 7 chip allowed the same kind of raster image, not only stretching, but also like, not only scaling, but also like trapezoidal stretching, which was used for like map screens in games like Final Fantasy VI and stuff like that. So, do we feel we understand the difference between vector and raster images? Okay, good. So, forgive me. You ended up with a nerd for a professor. So, we shall create a scaled vector graphics object within an HTML page. Scaled vector graphics are an XML encoded graphics engine. What does it mean to be XML encoded? It means it's encoded in the same way as HTML. So, you're still going to be dealing with tags, you're still going to be dealing with elements and properties of elements, and now it's just going to be an image instead of being like, you know, paragraphs and buttons and things. So, if everybody could please create your basic HTML page template type thing, we'll get underway. If you're working in an editor that has an Emmet abbreviation, probably use that. Notepad, for all of its good points, doesn't have an Emmet abbreviation. If there's one thing these people, programmers who type for a living, hate doing, it's typing for a living. So, scaled vector graphics. You create an SVG object in almost exactly the same way that you would expect to. Ta-da! Pretty basic. Now, similarly to a div, it doesn't show up unless you give it a border. So let's give it a border. You can also, incidentally, you can apply CSS properties to these things. I know you're not supposed to use style blocks, I'm going to do it anyway. Save the thing. Call this index.html. Sorry, just give me a moment. One of the traditional problems with these things is like they need mouse pads. but like I guess people keep stealing the mouse pads or something, so people like put pieces of paper down, which is okay as a solution. It is a solution, and it occasionally works, but the paper rips over time and you have to like re-punch the thing through it. I hate everything. Ugh. I don't hate everything. I don't hate cheese. And I don't hate my children. And I don't hate my wife. But I hate technology. Whoever came up with technology. Terrible idea. Alright. There we go. Now my mouse is working semi-correctly. So let's load that bad boy up and see what we can see. Ta-da! So we get a nice little, probably 100 pixel by 50 pixel little window into the universe. That might be a little small. Let's make it bigger. Pixels, maybe? Sure. Zoom in a little bit. There we go. So, all right. This thing functions very similarly to the canvas object in JavaFX. Basically, you'll be able to produce very similar outputs using this as your canvas. Sound good? So let's make some objects. Let's begin with the humble rectangle. Ta-da! Now, let me ask you a question. Is that easier or harder than Java? How many people think it's harder? How many people think it's easier? You're correct. Good job. So, there are, however, a couple of small gotchas here. They don't show up until you have two things on screen, though. So let me just duplicate the rectangle and move it over a little bit. There we go, now we have two of them. Normally, in HTML mode, you can get away with a little bit of improper formatting, and nobody really cares, and it's fine. You get away with less in SVG. These tags are self-closing tags, right? There's no pair of tags, right? There's no pair of tags there. Self-closing tags, according to the technical specification, are supposed to have a little slash at the end like that, right? Most of the time for self-closing tags, you get away with not including those. Not in SVG, my friends. Also, that space character right there is not optional. Let me show you what happens if you forget that. And you will forget it. Only the first image is rendered. Even if you remember the slash but forget the space, not only is the image not rendered, you see that like y is now still its default value of 0. That's because the attribute is using the space to tell where the attribute ends. In fact, we have not assigned 50 to y, we have assigned 50 slash to y. Right? Which is an invalid term. So, you must make sure that all of your tags are properly formatted. Make sense? You don't have to worry about doing this when we eventually get to creating these things from within JavaScript. That will all be handled for you by the engine. Make sense? So far, so good? You can add color, stroke and fill. Like so. Now, is that easier than doing it in Java? So far, so good? Any questions? This should be fairly straightforward. So let's go through a few more basic shapes, and then maybe we can do something fun. Let's do circles. So, a circle, in order to define the geometry of a circle, we need three pieces of information. What are those pieces of information? Radius is one, yeah. X and Y, yeah. So with a circle, we take x and y to be relative to the center of the circle, right? Whereas, does anybody know where on this rectangle the point xy is?
Isn't it the bottom left?
Bottom left? Well, it's actually the top left. But you were very close. So, this is how the coordinate system inside of SVG graphics works. This point at the top here is the origin, 0, 0. Right? So, when you measure a point, this is y, this is x. It's a little bit tricky. Our intuitions state that a y value which is greater should be closer to the top, it should be higher, right? Instinctively, positive y should go up, right? But in actual fact, in SVG as well as in JavaFX, positive y goes down. Does that make sense? You actually find this to be the case in lots of different engines. Yes?
A couple of weeks ago, I posted a extremely helpful article with a bunch of visualizations
Cool.
for SVGs.
Send me the link.
It's in the discussion.
Oh, well there you go. It's in the discussion. Discussion.
Yep.
There you go.
Right at the bottom.
There you go. there you go. Yeah, these are some nice, yeah. Yeah, these are the things I'm doing on the board. Very good. Okay, I recommend this article. Reference on all of your basic shapes. Very good. All right, I'm going to keep doing my lesson though. So circles. We need to know x, y, and the radius. The attributes that you have for that in SVG are center x, let's make that maybe 300, center y, let's make that 100, and radius, which we will, r for radius, let's make that, oh, I don't know, 45. And you have, I think, the logo for something, I'm not sure. Yay! So, one of the problems that SVG solves is the problem of everything becoming pixely when you try to scale it, right? You have basically two approaches to this problem. The first approach is to just make the image file really big so that it works at any resolution. But as monitors continue to increase in resolution, more and more and higher pixel densities, they will eventually break you, right? If that was your strategy for, not having a pixelated logo, might be 10 years down the line, might be 20 years down the line, but technology will eventually break your logo. Technology will never break an SVG logo. In fact, if we just take a look at logos, is this like real logos? No, these are just fake logos made by stupid AI. I want real logos. Are these real logos? They look like that contains real logos. There we go. So, what makes a good logo? First of all, you can tell that from the JPEG artifacts on this very image that this has been done in a raster format and not in an SVG format. But basically, many of these would be quite easy to do using a vector graphics system. All of the two-tone color ones are very easy, right? Sorry, one or two tone colors, right? Like that one, that one, that one, that one, that one, that one. This one, that one, this one, that one, right? That one, no. That one would not be easy using vector, right? That would be very complicated. You would require an actual artist to do that. If you include the fact that many vector graphics systems allow you to add gradients, that gets you to most of the rest of them, right? This is actually a very simple logo. It looks more complicated because of the gradient going on in the middle, right? But it's really quite simple, actually. In fact, if you'll notice, the Windows logo has become increasingly simple as time's gone on. That's an interesting. Let's take a look at the Windows logos over the years is correct. So this is a little bit of a joke, right? They don't really have anywhere to go but, to just make it, to take out the cross, But yeah, let's assume that like Windows 3.1 was the first real Windows operating system, which is kind of true. It's the first one that was kind of largely mass marketed. That's actually a fairly complicated logo, right? Then we just kind of rotate it to make it look a little more dynamic, right? We take out the black and all the little squares. We try putting it in a circle, but we don't like that. We go back, right? Then it's just, you know, you're looking sideways at like just blue squares. You're looking at a slightly less oblique angle at the same blue squares. They eliminate the blue oblique angle completely, right? Evolution of logos. You can actually, it's very interesting. You can like detect the same trend in like commercial jingles, right? Like if you go back to like the 1950s, if you have like, you know, a soap company, they'll do a little jingle like, everybody loves soap, especially ours. Buy our soap, yeah, yeah, yeah. And it's like a 14-second like little musical ditty. And then like by the time you hit like, you know, 5 or 10 years ago, it's like you're lucky if you get 3 notes from a song all together and that's your thing, right? But anyway, all very easily represented using SVG graphics. Just in case you are wondering, do people actually use vector graphics in the real world? Yes, they do, for stuff like this, right? That's kind of a funny joke. I like that joke. Actually, overuse of gradients is one like strong indication that you're looking at something that was designed in a vector graphics system. So, lines. Geometrically, how do we define a line segment?
Like a start and an end.
A start and an end point, yes. Ooh, here's a test of your geometry. Do you guys know the difference between a line, a ray, and a line segment?
A line continues infinitely. A line segment is between 2 points, and I'm not sure about an array.
A ray is like a line, but it only continues infinitely in one direction. We actually use rays in programming. Has anybody heard of ray casting? Ray casting is a technique used inside of graphical engines for the purposes of rendering. So yeah, we do actually use rays. So in SVG though, when it says line, it means line segment. Oh no, it didn't show up. Because you have to give it a color. Ta-da! You can also modify line width with the property which I believe is called line width. So far so good? Any questions? Okie dokie. A couple more of these, and then we'll get to some JavaScript-y type stuff. So, having line segments, you may imagine, ooh, maybe I can like draw the outline of something using line segments. Managing it with a series of these line objects is not convenient when you're working in this sort of a format, so there is another element type that allows you to do multiple lines connected together, and that is a polyline. Rather than taking x1, x2, x3, x4, it takes a comma-separated list of numbers which are interpreted as x, y components of a series of dots. So, for example, 400, 400, 400, 500, 500, 400, 500, 500. Stroke color will be, give me a CSS color.
Blue.
Something more interesting than blue. Blue is too blue.
Orange.
Something not in the standard spectrum.
Peach puff.
Thank you. Peach puff. Although I don't think peach puff shows up particularly well. Khaki. Khaki is a really gross color in CSS. That doesn't show up very well either.
Rebecca purple.
Rebecca purple. None of these are really showing up very well. Let's set the fill color to something else. Perhaps even none. There we go. By the way, if you want to turn the fill off, none is the value that you give it. So, there we go. We have a polyline. Now, as you can see, when that did have a value, we get kind of an interesting behavior. Polylines do have an area inside of them. That area is, which is kind of a strange thing because it's not a closed geometric figure, right? It doesn't have an area inside of it unless it's a closed figure. These are not closed figures. What the engine does is it simply puts kind of a ghost line in between your start point and your end point and considers everything inside of that to be the fill area. Does that make sense? You may say to yourself, ooh, that seems like, why wouldn't I just, I'm missing a line segment. Do I really have to put the last one in as the first one? And the answer is no. You can actually convert a polyline to a proper polygon by calling it a polygon instead of a polyline. That adds that final line in there, and now you have a closed geometric figure. Make sense? Any questions? I know this part has been like fairly boring. Don't worry, we're gonna get to some interesting stuff. So, I'm going to take a moment now, introduce assignment 3. Then, depending on how long that takes, we might have the break, and then when we come back, I'm going to show you how to do, and animation. Which will be interesting. Yes?
Vector animation?
That's right, my friend. We're going to take something, not this specifically, we'll do a new one, but we're going to take this engine and JavaScript, and we are going to basically put together the rudiments of a physics engine. Just simple stuff, though. Not like collision detection or anything. Just like, how do I simulate, motion, maybe velocity, acceleration, that sort of thing. We're not going to do fluid simulation, unless you guys really want to do fluid simulation. Alright, let's take a look at assignment 3, shall we? So, in my personal consideration, assignment 3 is a bit of a lightweight. It's not too bad. So, it's kind of easier to just show you. Steve Adams, who put this assignment together, prepared a video demonstrating the assignment. This is that video. The purpose of this assignment is to exercise event-based programming in JavaScript. So, you have, it's like not quite a slot machine-ish kind of thing-ish. It's like the worst slot machine ever made. Basically, you have 3 images. In the back end, you have a bank of 9 images, right? And it randomly selects one of those images. When you click on one, it plays a little CSS animation. When you click the randomize button, it randomizes all 3 without playing the CSS animation, right? So basically, it's like you're just kind of swapping images around, and that's most of what the thing is doing, with a few additional bells and whistles. The images themselves, there should be 3 distinct categories, and there should be 3 images within those 3 categories. There is a requirement when the thing is initially loaded that you have 1 thing from each category displayed. In this example, it's cats, paw prints, and stars. But what those categories are is entirely up to you. I've seen people do it like, oh man, last year someone did Adventure Time, like all of the characters from Adventure Time. That one was pretty well done, actually. Like, it doesn't have to look this basic. You can give it a background, you can give it a theme, right? In terms of technical requirements, there are a few other things which are required. You have a countdown timer. When the countdown timer reaches 0, it's as if that... Come on. There we go. When the countdown timer reaches 0, it has the same effect as clicking the randomize button. You are able to set the timeout using a form element. The page keeps track of how many times images have changed, but that's like most of the important parts. Does that make sense? For a diligent student who has been sort of paying attention and doing well in the course so far, this assignment shouldn't take you an extraordinary amount of time. Please test it on CS Unix to make sure that your images load. Alright? If your images don't load, like there's almost nothing left, right? I can't give you very much if your images don't load. And you've got to test your code before you hand it in, right? Man, in a previous semester, I had a student in who, like, I was actually talking to them about an academic integrity case, and the student, like, basically also wondered, like, I made the offhand comment, you know, this stuff wouldn't compile anyways, so it wouldn't be worth much anyways. The student said, and I quote, how can I tell if it compiles before I hand it in? And I was like, by compiling it. So please, at least compile your code before you hand it in. The bit that kind of activates the CSS animation, you're given a little bit of JavaScript code which you may or may not take advantage of. It's there for your use if you wish. Store your image files in a 3x3 two-dimensional array for ease of access. Sorry, your file names. Miscellaneous requirements. There's a range requirement on the timer. Make sure that it's inside of the range specified. But, yeah, a couple of notes on attempting to solve this one. Don't try to do everything using one timer. There are, you know, you should have individual timers for each of the individual things going on. Don't wait until the last minute to do the assignment. You have a great deal of liberty to implement the design in the way you consider appealing if it meets the requirements. So, you know, try to impress me, right? I am impressed by nice looking things that don't just look like the default values of like whatever it is you're using, right? I'm impressed by looking like you put some effort in, right? Yeah, basically. Any questions about assignment 3? Someone in the back of the room says, I already finished it, sir. Alright. It's a little early for the break, but you guys mind if we do the break? We're kind of like between segments. Yeah? Alright. Alright, let's have a 15-minute break. Please be, I'll give you the extra minute. Never mind. 10:25, we shall resume class. Thank you very much.